Pythagorean identities. So last time I showed to you the fundamental identities, and these are the fundamental identities. There are 6 of them. Now let us go to the Pythagorean identities. So the title of these identities, or how these are described, is telling to you that, hey, this may have to do with the Pythagorean formula or the Pythagorean theorem. And so this may have to do with your right triangle, okay? So let us say this is your right triangle. I'm sorry for so my hands are shaky right now. So bear with my handwriting right now. So if this is C, A, and B, and you know how the Pythagorean looks like, or the Pythagorean theorem, a theorem looks like, it is this. C squared is equal to A squared plus B squared. The square of the hypotenuse is equal to the sum of the squares of the legs of your right triangle. So right away, this is suggesting to you that the Pythagorean identities may have something to do with the right triangle and the Pythagorean formula. And so these are the Pythagorean identities. The square of sine of t plus the square of cosine of t is equal to 1. 1 plus the square of tangent of t is equal to the square of secant of t. 1 plus the square of cotangent of t is equal to the square of cosecant of t. So why is this so? Okay. Why are these Pythagorean identities true? Well, we have to go back to your unit circle and to how we are defining your trigonometric functions. So we shall trace again an angle or an arc in your unit circle, okay? And that arc has an endpoint, and the coordinate of that endpoint would be xy. And guess what? That endpoint actually defines a right triangle, okay? That endpoint actually defines a right triangle with legs xy. So this is going to be the vertical leg, y. Okay, the length of that leg is y. The length of this is x. And then this one is the hypotenuse, which is the same as the radius of your circle. So this is where the Pythagorean part of the Pythagorean identities will come in. That point xy, the terminal point of your angle, defines a right triangle with sides xy and whose hypotenuse is equal to 1. What does that mean? What does that mean? Well, it means that the square of x plus the square of y is equal to the square of the hypotenuse. Okay? But what is the square of the hypotenuse? The square of the hypotenuse is just 1 squared. Why 1? Because this is a unit circle, okay? That is a unit circle, and the radius of that unit circle is equal to 1, okay? So x squared plus y squared is equal to 1, and guess what? Your x there and your y there are cosine of t and sine of t. And so by substitution, the square of cosine of t plus the square of sine of t is equal to 1. So this basically is a Pythagorean statement. Okay? So this is an equation that is directly a result of the Pythagorean theorem or the Pythagorean formula. Okay, so what else? How about this? 1 plus the square of tangent of t is equal to the square of secant of t. Since we have shown that this is true, let us use this. Let us use this to show that this is also true. Okay, so given this, what you will do is, let us divide that by, or let us multiply that by 1 over the square of cosine of t. Okay? And let us see what will happen. The square of cosine of t times this, so that becomes the square of cosine of t divided by the square of cosine of t, that is just equal to 1. And then we shall multiply this to this. It's going to be the square of sine of t divided by the square of cosine of t. And then 1 times this is 1 over the square of cosine of t. And guess what? We can write this, okay, we can write this in this way. It's the square of sine of t divided by cosine of t. And this one, we can write it as the square of 1 divided by cosine of t. And we know what this is equal to. This is your fundamental identity, or one of your fundamental identity. That is equal to tangent of t. And the same with this one. This one is equal to secant of t. And so by substitution, we are led to your second Pythagorean identity. So I will show you the fundamental identities and the Pythagorean identities. So these are our fundamental identities, and these are our Pythagorean identities. You know, I can remember my days when I was a student. I have difficulty recalling what goes with tangent and what goes with cotangent. Okay, so it's easy to remember this one. It's easy to remember that. But this one, these two can be confusing. So what goes with tangent? Okay, so here secant goes with tangent, or tangent goes with secant. But you know, when I was a student, well, maybe not. Maybe it's cosecant. So this pair of trigonometric identities can be confusing. If you want to remove your doubt, what you do is you derive these two from this one. Okay, derive these two Pythagorean identities from this one. The square of sine plus the square of cosine is equal to 1. And how do you do that? You multiply 1 over the square of cosine of t, and that will lead you here. And to derive the second or the third Pythagorean identity, what you do is you multiply this by 1 over sine. 1 over sine of, or the square of sine of t times this, that's equal to 1. This times this is equal to the square of cotangent. And when you multiply this to 1, that's 1 over the square of sine of t. And that is basically the square of cosecant of t. So that is how you do it. Okay, so when you cannot recall exactly the form of your Pythagorean identities, you derive them from this Pythagorean identity.